Hello, can you hear me?
Yes, sir.
Okay.
Yes, sir.
So this let me start the class, but before that, I want to make one announcement and I want to discuss one thing. Uh, uh, the announcement is that department has asked the teachers to conduct mid-sem exam before Dashera. So your mid-sem exam, I'll ask HOD because I have taken nine. This is my ninth class, but many teacher has taken 3, 4 classes. So I don't know whether it is good idea to take the exam before the SERA, but it is not in our hand. If department asks us to take, then I'll take that exam. You may be prepared for your exam before the Shera. That means it can happen before the vacation starts. So this next week itself. Uh, okay, so this is the bad thing about you. And I wanted to take the offline exam because most of you are here. But in this situation, we cannot take a offline. We'll take a online exam because already few people has left or planning to leave in a day or two. So this will be good idea to take the exam only on online. Okay, so nothing to worry about that, but online exam, even for my exam, you have to worry because you have to study. uh, Second thing is that Utkal Dixit, are you here?
Yes, sir. Present, sir.
So what is your problem now? Tell me in front of your classmates what is your problem.
Yes, sir. Sir, so just a minute. I have a list of my problems.
Yeah, you tell the main problem of attending
Sir,
this class.
the main problem is, sir, I am used like a toy by my classmates. Mainly Vinamra Sinha, Mansi More, Nandita, Sivesh, Satyam, lots of people. And now they
Hmm,
are threatening me. First, they used me. Then they ragged me.
hmm.
Now they are threatening me. Sending nude pic of girls in a group, IIT Jam group, official group, where seniors are
No,
present.
no, no, no. So I'm not interested in your group or whatever. I'm only interested related to this class. If you have a jam group and there some friend are behind you or there something is happening, I'm not interested at all. It may
So that's
happen
why I
some.
didn't tell it to you. I was going to talk to the HOD himself and the police.
So you can write to
That's what
HOD.
Stan sir told me to do also.
Ha
Our
ha.
practical lab teacher, he told us that this is not his department. You must talk to the dean or either the HOD. I will do it.
Yeah. You can complain to the HOD, dean, police, whatever it is, depending on the situation. But my question is that what you are facing, what was the problem, or what was the thing done bad for you in for this class? I You told me that you were uh, mm, uh, not allowed to join this group, or you are removed from the this group, BPT 502 group.
Yes, sir.
Yes. So who you think that has removed you?
Sir, I don't know, sir. I was removed. I don't know. TS, maybe someone. I don't
Yeah.
know, sir.
You don't know, but when somebody is removed, you get a message, na, removed by somebody or something,
It
or
got, sir, deleted. That group got deleted, sir.
no, group is not getting deleted. Group is there. That is why we are all are here.
Sir, deleted group.
Group is not deleted. Somebody,
Yes,
probably lot of admin people are there, and many
sir.
people are admin. So
Yes,
a
sir. Yes.
admin can remove. Yeah, a admin
Sir,
can remove any.
I have a
Now tell
suggestion for
me.
that as well. Only let, sir,
No,
teacher remain admin and only admins are allowed to send messages.
no.
Do
I'll
that, sir.
I'll not. I'll not want. I don't want to be admin. I don't have time to include student, and this student will be admin. But let me see
Sir,
that.
then,
No. But let me find the problem. No. Uh,
sir,
so
you can
who
see,
among you are? No,
I don't
please
know, sir.
keep quiet.
Okay, sir.
Utkal, you just mute yourself. So among these students who are in the admin, then not all students are admin. I can see who are the admin. So, and one of the admin is responsible for removing Utkal Dixit from this group. So, who is removing him? Can anybody? I can find this also. But I am giving an option to the students that you should admit that and why you are removing him. As far as attending the class, everybody has right to attend this class. But if one student is complaining that he is removed from this group, I'll take this. He has many complaints. I don't want to take those complaints, but I want to take this complaint seriously. Why somebody is removed from this group? So and this the admin, the student admins are responsible. So if you find yourself who is doing that, and if you admit to me that I am doing this and this purpose, uh, just frankly write to me. Otherwise, I'll penalize all the admin. I'll assuming all the admin are removing him. So that is up to you. Those who are in admin among the students, those who are admin, if you admit that I am removing Utkal Dixit from this group, better. I'll think of that what to do with you. You can privately write to message to me. If you don't do that, then I'll assume that all the students who are in admin are responsible for equally for that. Okay, and whatever punishment or whatever thing, you'll be in my bad notice, right? You'll get see, I don't want to give punishment to the student, but I'll not like you. That's simply that, and that is good enough for. I'll not give you good recommendation, I'll not do good for you, but I'll all the admin people. So it is responsibility for that particular admin person to admit that I am removing Utkal Dixit. I'll settle that job. If you don't do that, then I'll assume that all the students who are in admin are responsible. So it is those who, the student in the admin, those who are not responsible, their job is all to find that who is removing him. And henceforth, if this he is removed or he from this class, then I'll take a serious punishment. I can put it into a cyber cafe, and who has ever removed this person is in 10 minutes job to find that person name. I have a lot of friends in cyber who can help me in this cyber crime branch, and then they can find who has removed, and then I'll take a legal action. But now all of you are my student. I don't want to take a action with you, but at the same time, you be honest to admit that I am doing this. Okay, this job is done for the time being.
Sir,
The culprit should admit to me privately, or if you want, if you have courage enough, you can admit in front of all that I am doing this. If
sir,
there is any reason,
yes, sir, I was saying that Utkal told me someone was removing him, so I have removed all the student admins from admin position. Only you and Krishna sir are admin. They cannot remove anyone now. But I know who removed him.
so do you know who removed
Yeah, yes, sir, yes.
who removed Utkal Dixit and why?
Sir, I know the contact number. It is showing in everyone's chat.
So you share the contact number who has removed. Then I'll talk to him.
Okay, sir.
Yeah, you just send me to. If you don't, you just send it to me and in my WhatsApp, and I'll talk to that student. He's a student, right? Or why
Uh,
he is?
Sir, that I don't know, but somehow he was made admin by one of us, one of those who were admins, because when I asked you to make group, I made group on your permission, and then since I did not know everyone, so I added some students of our class, and someone of them made this person admin. I don't know who he is, but contact number is showing.
Okay.
Sir, I know the contact number and the person, and I will message you in personal WhatsApp.
Okay. 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 But you all are friend and all are student equally important to me. So this is a very not so good thing to happen within one of your friend. He is complaining that he is being ragged. If he complain to the dean that he is being ragged by this person, then you know you will get a, even you can suspend from the university. Ragging is very serious offense in BHU. All of you know, and it serious action will be taken. But
Yes,
I
sir.
don't
That's
know.
why I told him to talk to you because you are authority.
Yeah, so okay, it is good that this we the two teachers are the admin, and we never bother about this. Anybody join, will add him, but will not remove anybody unless there is some misuse or abuse of this group. Then nobody will be removed from the group. Okay, okay. So this is done for the time being. So those who has information, then just share with me in private WhatsApp, and I'll take care. And Utkal, nobody will remove you now for the time being. So please concentrate on your studies and on your things. And anything happen, particularly with this group, that you are being removed or something, then I'll take care of that. Okay, don't need to send me 1,000 message, Utkal. This is also another thing. That since yesterday you
Okay.
have sent 20 messages, but don't send that many messages. Also, nobody should use this classical mechanics group for your personal informations or any other topic. You student must have their own personal group. We are not there. We don't bother about what activity is going on in that group. But in this group, only something related to classical mechanics will be shared. So I am saying to everybody, no other thing can be written in this group, only regarding classical mechanics. If it has some relevance to the classical mechanics, then only you can write in this group. Okay. Okay. So now I'll go to the usual procedure. Do you have any question? Regarding last lecture, then we will study. And also, I'm very surprised that only 34, 35 students are present. But now the exam is there. We'll have, see, in my exam, you have to solve some unseen problem. I'll give you a problem set, but your question paper will not be there from the problem set. My problem set are designed in this way that if you solve those problems, you will able to solve that unseen problem. But I'll not ask you directly from a problem set in this exam. So mid-sem exam offline, it will happen, but from my part, you will see unseen questions. Unseen in that situation, not discussed in the class, not given in the problem set, in that sense unseen. If you have seen, many people can see many other question, many other books, so it may be seen to somebody else, but unseen in that sense that we have not discussed. Okay, so you have to, and if the exam is postponed to later, we can have a better exam in that sense that more topic will be there. Right now, we have only topic that generalized coordinate degrees of freedom and construction of Lagrangian Hamilton's principle. So this is a very little topic, but exam can be conducted in any topic. So no problem with that, because I'll ask you problem only. Okay.
तो एग्जाम का एग्जैक्ट डेट क्या है? एग्जाम का एग्जैक्ट डेट क्या है?
No, there is no date, exact date, but there was a decision in the institute, not in the department. Institute level, there was a decision that mid-sem exams would be conducted before Dussehra. And this message our HOD has shared to all teachers in our teachers group, that please conduct your mid-sem exam before Dussehra. So no exact department will give exact date or not, that we'll see. Okay.
तो एग्जाम ऑफलाइन होगा या ऑनलाइन?
That also we don't know, but certainly the classes are going on online. So some student in principle, if they are staying at hostel, can demand that exams would be online. So most likely exams would be online, but Monday I'll talk to head and then I'll convey you in the group. because it is not clear from the head notice. Head given only message that mid-sem exam, but I don't think that most of the teachers will able to conduct, because only 1 week and time, and you have I don't know whether student has teaching holiday or not. From see 9th is Saturday and 10th is Sunday, so 11, 12, 13 is your working days for the student or not? It is working day for the teachers, but for the students, I don't know. Generally, student get 1 week holiday, but here I don't know, because this is a pandemic year and your classes has started late, so I don't know exactly, but otherwise it is 1 week generally holiday for student during Dussehra. 14, 15, 16 I know it is a holiday, BHU holiday. So and 17 is but it is not that hard and fast as I believe, but from the department point of view. But if there is a notice from the department, I'll prefer to follow the notice. Okay, so this is my point of view. If department give a relaxation that okay, you can take after Dussehra, I can take after Dussehra, no problem, because we have studied only very little. A lot of thing in classical mechanics is remaining, and also I don't think Dr. Kista has taken more than 2 or 3 classes, or maybe 4, but he's taking 1 class per week and it is only 1 month. This is my it is 8th or 9th class, but okay. So today, since you don't have question, today we'll learn symmetries and conservation law.
सर 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 लास्ट क्लास में सर जो क्वेश्चन दिए थे सर सर वो क्वेश्चन सर समझ में नहीं आया सर, उसको सॉल्व करने की सर उसको कोशिश।
If you say that I cannot solve, I can understand, but question समझ में नहीं आया कि क्या क्वेश्चन है बताओ, what was the
नहीं
question?
सर क्वेश्चन समझ में आया, मतलब सर सॉल्व किए थे सर, उसका सॉल्यूशन सर वही सर नहीं आया। अब समझ नहीं आ रहा सर सही है कि गलत है।
हाँ तो वो आंसर दिखाओ हमके, आप मैसेज करके भेज दीजिए, आप आंसर भेज दीजिए, ठीक है ना, हम बता देते हैं।
ओके सर।
So we'll discuss 3 symmetries. First is that translational symmetry. Translation, you can see my I'm sorry, I don't know, you cannot see my whiteboard. Why? Let me pin again. Actually I was writing in my whiteboard, but okay, so I have to share again actually then, or I don't know whether I have left from the meeting or not. No, I have left the meeting. Why? Okay, so now I should, okay, so then I have to share, right? Just a minute. See, what should I do? This JP Gupta. Let me in and then out. Okay, JP Gupta, you will wait for me. Okay, so this is that thing. Let us study this and we want to make it bigger, but anyhow, this is fine. JP Gupta, who is JP Gupta? Hello.
Hello. Good morning, sir.
What is the time now?
Sir, I become late
So it
sorry
is
sir.
not time to the नहीं sorry नहीं आप leave कर जाइए, just leave the
Okay,
meeting. हाँ, and never come again give any. First thing, you have to be disciplined in this class. Okay, so translational symmetry. What is the meaning of translation symmetry? If your system dynamics remain invariant under the translation of coordinates, say this is my position vector of ith particle, and if it is say invariant under a constant shift, this is basically choosing the origin at a different point. So suppose this is my origin, and say initially it is 0 0 0. Now that position vector is r, or maybe r, and this position vector I am writing r prime equal to plus this r vector. Let me put a vector, then this epsilon vector. That means that this position vector is now shifted from 0 0 to epsilon 1 epsilon 2 epsilon 3, because epsilon 1 epsilon vector is your epsilon 1 times I, epsilon 2 times j, and epsilon 3 times k. Then this shifted. So translational symmetry means if the dynamics of a system remains invariant under the translation of the coordinate or translation of the generalized coordinate, then we can call it a translational symmetry. When the system has translational symmetry, then the space is called homogeneous. This I told you when I discussed the one free particle Lagrangian. The space is always homogeneous for free particle. Okay, so space is homogeneous is equivalent to say that system has translational symmetry. Okay, now whenever you have a symmetry, there is a conserved quantity. So what quantity will be conserved, that we are going to find. So Lagrangian, suppose consider only I write in terms of this vector, position vector, and then velocity vector or dot, and then suppose t. So this is my Lagrangian. Now if it is a translational invariant, then we can their Lagrangian should not depend on the position, right? If Lagrangian depends on r, then when I make a change r going to r plus epsilon, then Lagrangian will change, right? So translational invariant means that this quantity will be 0. Okay. So if you have this Lagrangian, see, dynamics does not change. Dynamics, Lagrangian is responsible for the dynamics, or action is the responsible for the, so dynamics does not change means action should be invariant, or Lagrangian should be invariant, or it changes by total derivative, as I mentioned. So what will happen, this quantity, so Lagrangian is given by this. So let us calculate the change in the Lagrangian. Change in the Lagrangian will be del L del Ri times delta Ri sum over all I. If this is a vector, then this should be dot product, right? Plus del L del Ri dot, this is also vector, dot del Ri dot. Sum, again it will be also sum over I, all possible. If it is only one variable r dot and t, then it will not. Okay. Now if your r is going to r plus epsilon vector, then your delta r will be epsilon vector, right? This is the change in R. And delta R dot, this is epsilon is constant. Now we are assuming is a constant vector. So delta R dot should be 0. But I can use the Euler-Lagrangian. So this term will be 0 because delta R I dot, this is 0. Okay, for this transformation, and for this transformation, okay, this I'll come later. This right now I suppose see Lagrangian. This is not a solid statement because Lagrangian can change by a total derivative. That case del L del Ri may not be 0, but it is a special case of that. So for the time being, just don't keep it. So what will happen that now remember Euler-Lagrangian equation. Euler-Lagrangian equation is del L del Ri equal to ddt of del L del Ri dot, right? So what happened that now that I can write my delta L, which should be 0 because delta S has to be 0, action has to be 0. So this means summation over I'll substitute this del L del I by this relation. So I'll get ddt of del L del Ri dot vector dot epsilon equal to 0. But what is del L del Ri dot? This is nothing but pi, right? Other day I said that when you differentiate with respect to the velocity, then it gives you the momentum, corresponding momentum. This is a condition. This is a condition for cyclic coordinate. So, but for translational symmetry, it may not be cyclic. That it depends on R in a total derivative fashion. Okay, so those will come. So this is pi. So I can write epsilon is a constant. I can take right outside. So this is epsilon dot ddt of sum over pi. This is pi. So ddt I can outside and sum over pi. That means epsilon dot dp dt equal to 0. So p is the total momentum. P is the total momentum pi. So if I have a translational symmetry in the system, total momentum of the system is conserved. Total linear momentum. Okay, so this is the knowledge we get, that if your system has a translational symmetry, then we get the total momentum of the system is conserved. Okay, I'll come later towards the end of the class that if partially translational symmetry, then what will happen? But now we are considering that all R has this. And also you can, if I don't substitute here, from here we can see that delta L will be 0 only when delta L delta Ri will be 0, just from this relation. Of course, it can be add up, all these add up, then there will be a cancellation and that can be a possibility. But one solution is possible, that delta R that I was mentioning, that okay, so delta L delta Ri also will be 0 is also a solution. Okay, this means that Ri is cyclic. So we learned three things. One is that translational symmetry means change of origin. So if I by changing of origin your dynamics remain unchanged, then you can have translational symmetry, and that is called, if you have translational symmetry, then it's called pace is homogeneous. And if pace is homogeneous, then total momentum P is conserved, total linear momentum P is total linear momentum. Okay, and we find that in that case this coordinate is cyclic, or I is cyclic. So okay, so this is all information. Do you have any question? Otherwise we'll go to the next symmetry. So if space is homogeneous, if space is homogeneous means the position vectors are cyclic. It means that momentum, total linear momentum is conserved. Okay, so this is where cyclic coordinate, symmetry, and conservation law, they are related. Okay, so now let us go to the homogeneity of time, or translational time translation. That means physically the homogeneity means that dynamics, character of the dynamics of a system does not depend whether you are looking at your hostel, or you are looking at the department, or looking at the marketplace. So it is same dynamic. For example, free particle moves. So wherever you see, it always moves in the with same speed in a particular direction. Okay, so this is the called homogeneity of space. Now translational homogeneity in time. In time, or just a moment, I got a call, so let me give it to you. Hello.
Yes, sir.
Yes,
Huh.
sir.
Okay, let me continue. So homogeneity in time, so it is a invariant under time translation. So homogeneity in time means invariant, exactly in like space, invariant under time translation. So invariant under time translation. So means if you make a change t prime equal to t plus a, this is the translational equation. So under this, dynamics will not change. Dynamics will not change. Okay, so this and what will be the consequence that we are going to learn. So for that we can so for that again we can think of that this Lagrangian cannot depend on time. If it depends on time, then when I make a translation, then it will change. So let us calculate what is this quantity del L del T. So del L del T, again I can write that it will be del L del Ri dot delta Ri this is a vector. This I'm using a vector. You can also prove this with the help of generalized coordinates without using vector. This means that if I take with x, the x component, then this will be delta x. If I take y, then it will be delta y kind of. So you can compactly I write. So del L del Ri dot delta Ri. Okay. No. Just a moment. I did a mistake. I was delta L del T. So I'm not considering delta L. I'm considering del L del T. So this will be different. Let me tell you what will be the different. So when I take a total derivative, I should differentiate with respect to the coordinate, and that will be differentiated with respect to time. So this will be Ri dot, okay, and this will be Ri dot. So this will be Ri double dot, right? So this is the chain rule of differentiation. Chain rule of differentiation that I'm not considering delta L like earlier case, which I wrote here, and del L del T is 0, so that term will not be there. So let us see what is the consequence of this in the Lagrangian. So again, for this term I'll substitute from the equation of motion. Equation of Euler-Lagrangian equation of motion, del L del Ri minus ddt of del L del Ri dot equal to 0. So this I'll substitute. So I'll get I del L ddt of I get ddt of del L del Ri dot, then Ri dot plus plus summation del L del Ri dot with Ri double dot. Okay. But if I use that just a moment, there is some notation problem. Let me check once in my note. Actually, I was disturbed with that phone call. So just a moment. There is some notation problem. Yeah. Okay. Yeah, I got it. Okay, so these two terms can be combined as Ri double dot. You can write Ri double dot. You can write this is Ri double dot. You can write this as ddt of Ri dot, right? Ri dot double dot. So one time derivative I write. Now you can see that this is the time derivative of first term, second term unchanged. This is the time derivative of the second term. So these two can be combined as I ddt of del L del Ri dot Ri dot. Okay. This product rule of differentiation. So when I make a first differentiation, I'll get this term, and I'll with the second terms this. But this is a vector, so don't forget about this dot. This is a vector. This is also a vector. Okay. So ddt del L del Ri dot Ri. Okay. Now, so this quantity del L del T. So and I can combine this. So this quantity is ddt. I'm just taking left side with a minus sign, and then L minus sum over I del L equal to 0. Okay. So I am just taking this term equal. So what is this term that we want to see? For that, we need a mathematical formula that I am going to mention. Okay. So let me erase the upper part. So we are considering homogeneity of time. Okay. So there is a theorem in mathematics called Euler's theorem. So Euler's theorem. Euler's theorem, you know. So if you have a homogeneous function, say x, y, z, homogeneous means every term you will have the same degree. For example, homogeneous function of degree 3 means x cube, x square, a x square, y, b y cube, c x y z. This, you see, this term has degree 3, all x power. This has x power 2, y power 1, again degree 3. This has y cube, again degree 3. This is 1, 1, 1, so degree 3. So this is called homogeneous function. So in case of homogeneous function of degree n, so if f is a homogeneous function of degree n, then del f del x, x del f del x, y del f del y plus z del f del z is your n times. This is, I think, known to all of you. So if you have a degree of 3, so n should be 3, kind of thing. So this mathematical result, the Euler's theorem, I'll be using here to simplify this relation. What is this conserved quantity? So this quantity will be conserved, but what is this quantity? That I want to know. So for translational symmetry of space, we found that total momentum is conserved. Now translational symmetry in time, we are going to see that this total quantity will be the total energy of the system. Okay, that we are going to prove. So this quantity will be simplified, particularly the second term, using the Euler's theorem. So Euler's theorem is known to all of you. So let me erase now. So here, one thing I'll assume, this is approximation that the kinetic term, so in the Lagrangian we know is t minus u, and we are now assuming that this u is independent of velocity. So we at the beginning also we mentioned that this is depends only on coordinates. So u is only function of coordinates or generalized coordinate. And kinetic energy, we have not mentioned anything earlier, but kinetic energy, you know what is kinetic energy? Half m v square, right? So it is a velocity power 2. But in general, it is general, but in general, if you have more than one variable, then there can be v1, v2 term also. Suppose I have two particles, so it can be half m v1 square plus half m2 v2 square. Then there is a possibility that there will be a term v1 v2. So those are complicated system, but in general, what we will assume that kinetic term is a quadratic homogeneous function of velocity r I dot of degree 2. homogeneous function of Ri of degree 2. Okay, so this is the assumption we are making. This is a very good assumption. In most cases, in all cases, kinetic energy term is a quadratic in velocity. So it is a homogeneous function of velocity of degree 2. So if this is a homogeneous function of velocity, so this is the Euler, then this term is exactly in terms of left hand side of the Euler equation. So this term will be, okay, so let me erase and so then del L del Ri dot Ri will be 2 times T. Okay, why not L? That I'll tell you. See, del L del Ri dot is del Ri dot T minus U, but U does not depend on Ri dot. U independent of velocity. So this derivative will 0. So del T del Ri dot Ri sum over I will be 2T, because it is a homogeneous function of degree 2. Okay. So is that okay?
Yes, sir.
Yeah. So now I can substitute here. So let me write ddt of L. L is nothing but T minus U equal to 0. This is 2T. So now this is nothing but ddt of T plus U equal to 0. T plus U is the total energy. Okay. So this is the T minus 2T, so minus T, so minus T minus common, so minus right hand side, so it is basically T plus. So this is the total energy. So if you have system which is invariant under time translation, then total energy of the system is gone. So for a conservative system is a time translation. So for a conservative system, we can tell you directly that T is cyclic. So del L del T is time translation invariant, del L del T equal to 0. So for a conservative system, T is cyclic. Okay. Okay, is there any question? So one more symmetry I should suppose to cover, but let me start and then we have around 9 minutes. So do you have any question? Then I'll do. Otherwise, now another symmetry we'll consider the rotational symmetry. So these two are translational symmetry. Now I'll consider a rotational symmetry.
No question, sir.
No question. That is fine. I'm just cleaning my board and I'll come to the next symmetry. You people are very smart. You don't have any question. But I am little bit worried about you people. So that worry you can see after mid-sem. But anyhow, so this is now third symmetry we are talking, the rotational symmetry. Okay. So rotational symmetry means if you rotate your coordinate axis, then if you rotate your coordinate axis, then if the dynamics does not change, then we'll call the system as rotational symmetry. Suppose I make a rotation about z axis, and then whatever dynamics I was looking at before rotation, the same dynamics, then I'll say that the system is rotational invariant, or this is called isotropic system. So homogeneous system, now I am talking about isotropic system. Rotational invariant system is isotropic. Please remember these names because in exam earlier we used to get that what is the isotropic system and what quantity is conserved. Then people confuse with that. So the rotational invariance, homogeneity and isotropic invariance. Homogeneity is translational invariant, isotropic means rotational invariant. Okay, good. So now so let us consider an example. So let me draw a picture, and let us consider you have a this is your z axis, this is your say x and y axis, and you make a rotation about z axis. So this circle is actually perpendicular to z. So in my drawing it is not clear, but this is actually perpendicular. And suppose this is two consecutive points. So let us consider this is your P point and this is your P prime point after infinite decimal rotation. So so I'm considering, so this is my this is my R, and this is my R plus delta R. This angle let us consider as phi, and so I'm sorry for small picture, this angle is a delta theta. This between two consecutive point P and P prime. So this is your delta theta. Okay, I am taking a rotational invariant rotation about z axis. This is a partial rotation you can think of, but it is z axis. So my Lagrangian is L Ri dot and T, and we are calculating del L. So del L will be del L del Ri dot delta Ri sum over I plus del L del Ri dot and dot delta Ri dot. So this quantity we have to calculate from this geometry. So now let us consider this geometry. I said that this circle, this is z-axis is vertical, and this is a horizontal circle. So this angle is 90 degree, right? All this anything. So if you I cannot show you here, but this is the z-axis. You have the circle around this. Then all these angles will be 90 degree, right? Angles these angles with this z-axis. Okay, so now let us consider this say triangle say Q. Say this point is Q, and then let us consider this triangle Q, P and O. Okay, which one of the angle is 90 degree. That Q angle at Q is 90 degree, and so this is OP. OP will be your perpendicular distance. Okay, yeah, OP, OQ, QP will be your perpendicular distance of this angle. If you consider this angle is phi, and this angle is 90 degree, Q angle. So OP will be so QP by OP will be sine of phi. This angle is 90 degree, this angle is phi. Okay, and I am considering QPO triangle. Okay, so my QP this QP means this point to this point, right? QP.
Sir, Sir, actually,
Tell
we
me.
have less doubts because we have studied these things in statistics, maths,
Yeah,
dynamics, and rotational.
no problem with that. So left out means what? I didn't
I
get.
just, I just wanted to tell you that you were worried about us, but
Okay,
sir, we have already studied these things.
okay. You have studied this rotational symmetry, all these things, but no, yeah. Okay, so
Yes, sir.
OP is your R, right? This I said, this OP is R.
Yes,
So R sine phi. Okay. So now I am interested to calculate see delta R. This delta Ri. So let us consider even okay. Even if I consider for only one dimensional, so del L del R dot delta R plus del L del R dot delta R dot. So suppose only one. I only 1 degrees of freedom. So this will be not 1 degrees, but only one three-dimensional things. So this will be no. So I particles now only one particle. So delta R we need to calculate. So this is the delta R. This quantity is delta R. So the delta R will be delta theta or maybe d theta or delta theta. This small angle is delta theta times qp, right? This arc in the circular path is the radius times the angle, right? So delta theta times qp. So this will be r sine phi. So this delta r will be r sine phi delta theta. Okay, but r sine phi I can write z cross z unit vector cross r, because this is my z, this is my z, and this is r is my this, between angle is phi. So my delta r, then finally I get delta r is z unit vector z cross r and delta theta. Okay. So similarly, if I have delta r dot, it will find z cross r dot. This is r vector, this is unit vector, z is unit vector, r vector, and delta theta. Okay, that now these two quantity, how I am over, but these two quantity I'll substitute here, and then I'll get the interesting result. But I want to stop. You may have a class now, so I'll stop here. So if you have question, you'll continue from here, and in next class will be on Thursday, and by this time, this if I have to take exam, then if I have to take exam, I'll take exam Saturday. I may travel, so Saturday I'll not able to take your class. So instead of that, we can have your exam on Monday. So keep in mind that if department asks strictly that please take your mid-sem exam on before Dussehra, then Monday will you have exam. Tell me the time when you will be comfortable.
The date?
Monday. Oh, date Monday, 11 of October. Right? 9th is Saturday, 10th is Sunday, 11th is Monday. Online exam. No vigilance, no camera on. Okay.
Okay, sir. Actually, I'm traveling on 10th. That's why I was asking.
10th, but you will be traveling. You are famous, right? So you will be traveling by flight. So you will reach 10th, right? Or 10th is Sunday. So Monday, just tell me the time. Time I'll give you. It can be evening, it can be night, no problem. So fixed the time and tell me. And
sir, most probably in the evening, sir. We have classes also.
Yeah, you can have classes. I could have taken Saturday, but Saturday problem is that is there any? I can ask somebody to take the exam, but if I have problem, I'll be traveling. So you may not reach to me. So I want to avoid Saturday, but keep in mind, I'll try to postpone your exam after Dussehra. that I'll, but if head insists that no, you have to take because this is the notice, so we'll take the exam. But don't worry about, we'll take your offline exam when you, after puja, when you will come back, or after Deepavali, we can take your offline exam. Offline exam you will enjoy. That much better exam, right? Online exam, I don't believe. This student has their own WhatsApp group. Somebody will solve, put the answer to that WhatsApp group. Everybody will copy, and they will think that they are very intelligent. But offline exam I'll prefer, and definitely if there is no corona spread again, we'll definitely have your offline exam. Okay, let me stop here. Time on Monday. Tuesday is also possible. So in Monday, Tuesday, just think of your time. Tuesday, I will be in some remote place, but it is possible.
Okay, sir.
Okay, so let me end the class. Today I don't take attendance, but I noticed that only 30 people was there, and you have a group of 50 plus student, so I have to worry about that. They are thinking that they will copy in the final exam and they will get 90% marks, but this will not happen. Okay, bye bye.